Hey everybody, it's Mr. Kowalczyk. I'm here today to talk to you about section 2.1. We're going to start unit 2 today, which is called deductive reasoning. And the first section in that is 2.1. So today's section is called conditional statements and converses. Of course, the converses are on the screen for you to enjoy as well. Classic shoe, one of the best of all time. All right, let's see if we can get this slideshow started. There we go. Okay, so conditional statements and converses. Let's move on. Our learning goals are to recognize the hypothesis and conclusion of a conditional statement. Also, we are going to hypothesis and conclusion and conditional statements. Those are big words for today. State the converse of a conditional statement. What is a converse? That's another big one. The third one is use counterexamples to disprove statements. And finally, understanding the meaning of the phrase if and only if. Okay? All right, let's move on. Mark each statement as true or false. So what I'm going to ask you to do is to go ahead and mark each statement as true or false. Pause the video, take a look, and see if you can figure each one out. This word right here under my screen is midpoint if you can't make it out. Okay, welcome back. Hopefully you paused the video and you had a go at these. If B is between A and C, then B is the midpoint of AC. Of course, that is false. That is false because B could be anywhere in between A and C. It doesn't necessarily have to be in the midpoint. Number two, if B is the midpoint of AC, then B is between A and C. Absolutely true. Absolutely. You can't, be anywhere else but between A and C if it's the midpoint. It's got to be between those two. If the measure of an angle is 90, then it's a right angle. That is true as well. We know that that's true. If an angle is right, then its measure is 90 degrees. Well, that's just the previous statement flipped around, and that one is also true. So we've got false, true, true, true. Good job. Okay, moving along. This one you already took notes on, so I'm going to kind of breeze through this. A conditional if-then statement. A conditional statement has if and then in it. If a spider came into class, then I would take it outside. The hypothesis is that first part associated with the if statement. The conclusion is the second part associated with the then part of the statement, the conditional. A spider came into class, then I took it outside. If the hypothesis is true, then the conclusion must also be true, like we saw before with the previous example of the right angles being 90 degrees. Let's try some samples here. So, identify the hypothesis and conclusion of each example. Pause the video for a second, see if you can figure those out. Okay, welcome back. Number one, we've got Frodo and Beyonce mashed up in here. If you like it, then you should have put a ring on it. Hypothesis is going to be in red, conclusion is going to be in blue. Now, if you like it, then you should have put a ring on it. You like it is the hypothesis. You like it's the hypothesis, and you should have put a ring on it is the conclusion. Okay? Let's see about the second one, because it seems, I'm wondering if some of you made some mistakes on this one. If I start training pigeons, then I will be a fancier. I start training pigeons is the hypothesis, and I will be a fancier is the conclusion. Okay, starting to notice something. Now lastly, I can't study if Harry Potter is on. Now this one is a little different, right? Because the if statement is the second part of the sentence. So I wonder, yep, Harry Potter is on is the hypothesis. And then the conclusion is I can't study. So it's important to note in this that we don't necessarily need the word then to have a conclusion in a statement. Some of you have already noticed that the hypothesis and conclusions don't include the words if and then. So please note that, and that might just be on a quiz or a test. Okay, super important. The converse of a conditional, converse of a conditional, is formed by switching the hypothesis and the conclusion. Okay? So again, we took notes on this, so I'm going to kind of breeze through this. State the converse of this conditional. If a figure is a square, then it has 4 sides. We identify the hypothesis and the conclusion, and then we switch them to get the converse. A figure has 4 sides, then it is a square. Is it true or false? Why? Well, let's think about this. If a figure is a square, then it has 4 sides is our first conditional statement. Of course that's true. We know squares have 4 sides. But then if a figure has 4 sides, then it is a square. The converse, is that true? Take a minute and think about it. See if you can come up with an example that proves that to be false or true. All right, as most of you figured out probably right away, it is false. It's false. There are lots of examples that prove that it is not true, right? We have rectangles, we have rhombi, kites, etc., etc., etc. So just because the conditional statement is true does not mean that the converse is going to be true also. All right, so there's the statement from before. Let's take a look. To prove a conditional statement false, you only need to find one counterexample. If you can find one counterexample, then it is considered false forever and ever. So let's take a look at some more examples here. The counterexample, like I said, is an example that satisfies the hypothesis but does not satisfy the conclusion. Therefore, in the previous example, a rectangle has 4 sides but is not a square. That's a counterexample because it has 4 sides, proves the hypothesis true, but the conclusion is a square is not true. So let's take a look. Number 1, if an integer is divisible by 3, then it is divisible by 6. Take a second, figure out if you can find a counterexample. An integer divisible by 3, but not divisible by 6. Okay, some examples, 3, 9, 15, the list goes on and on and on. Lots of examples. So this one has way more than one to prove it false. Therefore, this statement is false. Number 1 again, a lightsaber is either blue or red. Star Wars nerds out there will know this right away. If you don't, let's go through some of them. Lightsabers, here we go. So we've got a couple different lightsabers. Red we have, they're used by Sith and Dark Jedi, kind of the bad guys who are down with the dark side of the Force, Darth Vader, Darth Maul, Kylo Ren, those kind of folks. And then the blue ones they're about justice and protection. Jedi Guardians who are down with the light side of the Force, kind of what's typically thought of as the good side. Obi-Wan and Anakin, before he turned into Darth Vader, they were using blue. All right, next, what else might there be? There are green and purple lightsabers. Green is used by folks who are mostly peaceful and only like to use Force when absolutely necessary. People like Luke, Yoda, and Qui-Gon. And then purple. Purple is used for really interesting characters who they're not so sure about how they feel about the light and the dark. Maybe they appreciate or understand a little bit of both. Mace Windu is one of those, and Mara Jade Skywalker was another. They understand that good and evil has this kind of duality to it. Therefore, what that tells us is that this statement is false because green and purple lightsabers are the counterexamples. So lightsabers aren't just blue or red, they can also be green and purple, or green or purple. Number 3, if x squared equals 81, then x equals 9. True or false? If it's false, what's the counterexample? Pause it and figure it out. Okay, welcome back. X squared equals 81, then x equals 9. This is false because x can equal negative 9. Remember, when you square root x squared, it gives you both a positive and negative number. So we can use negative 9 as a counterexample to prove this statement false. And finally, if q squared equals 7q, then q equals 0. In order to solve this, we can get 2 answers, q is 0 or q is equal to 7. Therefore, q equals 7 is a counterexample that disproves this conditional statement, making it false. Counterexamples. Counterexample, big word for this slide, proves things false. Last term for today, biconditional. Biconditional meaning to, and conditional statement meaning back and forth. There are two types of conditional statements we've talked about today. One is the conditional statement. The other one is the converse. A biconditional happens when both the converse and the conditional statement are true. Let's take a look at the first one. If A is congruent to B, then the measure of angle A is equal to the measure of angle B. The converse of that, if the measure of angle A equals the measure of angle B, then A is congruent to angle B. Now both of those are true. Both of those are true. Therefore, this statement is a biconditional. And this is how we write it. The angle of, angle A is congruent to angle B if and only if the measurement of angle A equals the measurement of angle B. This if and only if, that's our giveaway. When we see if and only if, it tells us that this statement is a biconditional and can be reversed back and forth. The hypothesis and the conclusion. We can also write if and only if as IFF, if and only if, or we could also write it as a double-sided arrow, which I pointed out last week. So that double-sided arrow, IFF, they both mean if and only if. Again, notation and writing shorthand and proofs and things like that, we're going to be doing a lot of that. All right. All of these symbols, like I said, mean the same thing. Last one for this slide is that this particular setup here is the definition of congruent angles. And all definitions that we go through this year can be written as biconditional. So we can reverse them if it suits our purposes when we're doing proofs. That's going to be really helpful and important. Lastly is your homework assignment for tonight. Today, please go ahead and start that. And as I said at the beginning of class today, at a certain point in time, please come back and join us for section 2.2 that we're going to be doing in class today after we're done with the homework time for 2.1. All right, hope this was helpful. I will see you in a little bit to start lesson 2.2.